Hey everybody, see some names I recognize in the call, some names I don't. So those of you that I already know, it's good to see you here. Those of you that I don't, my name is Brendan Evans. I'm a senior manufacturing consultant at Essential Software Solutions, and I work with a bunch of different areas of the SyteLean ERP system, but definitely with a focus around production, manufacturing, planning, and a lot of different concepts that are related to some of the benefits that can be obtained from lean manufacturing. So today what we're going to look at is we will explore how lean manufacturing principles can be effectively implemented using a program, an application called SyteLean within the SyteLine CSI ERP system. So we are going to look at how to implement lean manufacturing using SyteLean in SyteLine CSI.
Before we start, Brendan, I would like to show quickly the interface of the whole webinar. Dear attendees, if you have any questions, you can simply type them in the Q&A section. I will not. I try to interrupt try not to interrupt the speakers during the presentation, but I'll address all your questions at the end. And after the webinar, please don't hesitate to contact us if you have any questions. Please go ahead, Brandon.
Okay. Yeah. So what I'd like to do first is I'd like to talk a little bit about what lean management actually is. I'm sure everybody in this call has, at the very least, heard the term lean management. Most of you probably have a good understanding of what it is, and some of you may actually be lean certified organizations as well. For those of you that aren't as familiar, I'll just provide a little bit of background information here. So lean management, it's a methodology that focuses on reducing waste while maintaining high productivity. That's the main goal of lean management. Lean at its core, from the way that I've been taught, is reduction of waste. It is a strategic approach for a business, often manufacturing, but it doesn't have to be, that aligns with the goal of delivering maximum value to the customer and eliminating non-value added activities. There are 5 key lean principles that are defined in the industry. The 5 key lean principles, and really the 5 steps to implement a lean organization, is first to define value, which includes identifying what adds value from the customer's perspective, the end customer, and eliminating anything that does not. So in this case, value represents what the customer is willing to pay for. In some cases, the customer isn't able to articulate what they are willing to pay for. So you need to define what the value is through analytics. The next lean principle is to map the value stream. So mapping out all the steps in the process that you perform at your organization allows to identify and remove any non-value added activities. You can do this using process mapping, flow charts, etc. In this step, the mapping of the value stream, the goal is to use the customer's value as a reference point and identify all activities that contribute to the value. Activities that do not contribute to these values or do not add value to the end customer are considered waste. Waste can be broken into 2 different categories in value stream mapping: non-value added but necessary activities, and non-value added and unnecessary. So unnecessary activities are pure waste and should be eliminated in a lean system, while non-value added but necessary activities should be reduced as much as possible. The next lean principle is to create a continuous workflow. So creating a continuous workflow ensures a smooth and uninterrupted flow of processes that enhance efficiency of your organization. So some strategies to achieve this include breaking down steps in your production process, reconfiguring your production process, steps in the production process, leveling out your workload, leveling out production, creating cross-functional departments that coordinate, work together, and training your employees to be multi-skilled and adaptive. So one of the things that I see a lot in companies that I work with is they're looking for utilization at their organization. So they've got a machine, for instance, or an employee that they want to be busy 100% of the time. In a lean system, you don't want to keep someone busy just for the sake of keeping them busy. You want them to be actively providing value to a downstream customer. So training employees to be able to work in multiple different areas on the shop floor allows the employees to achieve higher utilization without working just for the sake of it. Final key lean principle is the second final one is to establish the pull. So lean management is structured around a pull system. In this case, we're talking about pull manufacturing. Pull meaning you don't make something until you need it. You don't make something until there's demand for it from a customer, from replenishment of a buffer of inventory, etc. This goes for every stage of the production process. Establishing pull means to produce only what's needed, driven by actual customer demand, so not forecasts. Under lean management methodology, inventory is considered to be one of the biggest wastes in any production system. So pull-based manufacturing, the core goal of pull-based manufacturing is to limit inventory and to limit WIP, while also ensuring that the materials and the people and the machines, etc., the resources are available for a smooth flow of work. So pull-based manufacturing systems allow for just-in-time delivery to end customers and manufacturing where products are created at the time that they're needed and not a second earlier, and the quantities that are needed and not 1 unit more. Now, the actual final step for the 5 key lean principles is the pursuing of perfection or continuous improvement. So any improvement that you capture at your business, whether it's lean management, whether it's new technology implementation like what we work with frequently, it's not a static thing. When you make this kind of improvement to your organization, it is a dynamic change to the organization that requires constant review and resolution of issues that arise, and it requires the entire organization to be involved and pulling in the same direction in order to continuously improve the business. All right, so hopefully that gives a little bit of a background about what lean management is and the 5 principles. So lean management in SyteLine, using the SyteLean process, it revolves around what's called an automated pull system. So pull systems in general are a lean strategy, as I mentioned earlier, that minimizes waste by producing only what's needed based on actual customer demand. So in a pull manufacturing system, each stage of production is triggered by demand from the next stage. So it's not pushed through the purchase acquisition of raw materials and then production based on the materials that you have on hand to build a finished good. It is pulled, so you have a buffer of inventory in each stage of production. And as that buffer depletes, that triggers the replenishment of that buffer from a prior workstation and production process. So for some of you that are using Kanban, it's going to sound really familiar. Full manufacturing systems lead to better inventory management, reduced lead times, and a more responsive production process. So they can help align production closely with market demand, improving your overall efficiency and reducing waste in the production process. So I have an image here for you guys. So this is a basic pull system logic. In this case, it's the famed bicycle example, the bicycle manufacturer. Those of you that have done an implementation in the last couple of years, you'll recognize that example. So the basic pull system logic works like this. The end customer, right about here, the end customer will create demand by purchasing finished goods. In this case, this is a make-to-stock organization, so we have a buffer of finished goods sitting in stock available to be sold to the customer. In some cases, if you are, for instance, assembled to order or make to order, you won't have any buffer of finished goods. The buffer will lie earlier in the production process. So it might lie at the raw materials, it might lie at the sub-assembly components. In this case, make to stock, the buffer is in the finished goods, well, one of the buffers. So the customer places an order that draws down the inventory in the buffer, that triggers a replenishment of inventory of finished bicycles. So the production of the finished bicycles, the work orders that get created for that, will draw down the buffer for each of the sub-assemblies. The drawdown of the buffer of each sub-assembly will trigger a replenishment of each sub-assembly. The replenishment of the sub-assemblies will draw down the buffer of the raw materials, which will therefore trigger a reorder of the purchase price. So the buffer of inventory is created before the operation of these materials. That's why we call it a buffer. And this goes for lean manufacturing. It goes for theory of constraints. Any kind of smooth manufacturing system, you want a buffer, generally speaking, at the very least at your critical workstations. So these buffers that I'm talking about here, as I mentioned, for those of you that use Kanban, this is going to sound really familiar. So Kanban is a way to replenish the inventory in each buffer using visual cues. So as an example, you might use something like a 2-bin system where when one bin gets emptied, the next bin gets pulled forward and the first bin gets sent to production to replenish. You may use a single card or a multi-card system to indicate when you require replenishment or when you're out of stock. So in SyteLine, we have a portion of the SyteLean module that is capable of recording Kanban transactions. So there is a Kanban management component to SyteLean. Even without using the Kanban component, if that's not something the organization does, this process here, this replenishment based on the drawdown of the buffer, this is something that exists in SyteLean as part of the core functionality and can be automated. So there's two areas that can signal an order prompt of a buffer, a reorder prompt of a buffer in an ERP system. The first one is the drawdown of inventory. The second one is the definition of that bill of material, the parent-child relationship. So what are the objectives of a pull system? What we're looking at here, the objective is to prevent overproduction, both in the manufacturing area and over purchasing as well. And those are controlled by two key factors: the inventory profile for each item, which we'll talk about how to set that up in SyteLean, and the current on-hand level of inventory and current on-order quantity of the inventories that you need for production. So the replenishment orders in a lean manufacturing environment will be based, as I mentioned before, only on actual consumption. So there will be no replenishment based on a forecast. That's not a lean methodology. That's not part of lean methodology. There will be no replenishment based on expected usage. All right, so that's a little bit of background on lean manufacturing and pull systems. So let's talk about how SyteLean fits into that. So SyteLean, as I mentioned before, it's a module that you can purchase a license for in SyteLine. For those of you in the call that are cloud customers, I did check, and it does come with your cloud subscription. So not 100% sure on the licensing, but from my experience, I was able to do some testing and perform transactions with the base cloud subscription. So if you're interested in finding out whether or not you have access to it, whether or not you're licensed to use it and you're in the cloud, reach out to me after this meeting and I'll let you know. I can check your system and confirm that. So SyteLean, it is an add-on module that is built around a full system solution that can be automated within the SyteLine ERP. So it's designed to support and enhance lean manufacturing practices. The components of SyteLean, as I mentioned, include Kanban management. So that's a key tool that's performed in lean manufacturing. For those of you that use Kanban, SyteLean has the full capacity to manage Kanbans in the system. So that includes single card, multi-card, electronic Kanbans, and so on. The next component is inventory profiles. So inventory profiling is an essential activity for maintaining optimal stock levels. It involves calculating information about specific item records by analyzing historical and future demand data. So for an example, it includes calculating your average daily usage, ADU, your safety stock levels based on service factors, your reorder points, your trigger points to maintain optimal. Another component of SyteLean is buffer management. Buffers, as we talked about here, they play a crucial role in managing the variations in demand and supply. The more stable your demand and the shorter the lead time to replenish your buffer, the smaller the buffer is. So buffers are strategically placed in your production floor to manage fluctuations in demand and supply. So the larger the variations, the bigger the buffer. SyteLean's buffer management functionality ensures that inventory levels are calculated and maintained to predefined limits, which will reduce or prevent, depending on your level of inventory, stockouts and overproduction. The final component of SyteLean is the automated replenishment process. So SyteLean is capable of automating replenishment orders, purchase orders, job orders, and having them get created automatically through the SyteLean process. It's not a required portion of SyteLean, but it is capable of doing that. So, so you can actually have it manage the creation of orders, and then you just have to send them out to the vendor. If it's a purchase order, send it to the shop floor if it's production. This reduces the need for manual intervention and ensures that the inventory is replenished in a timely manner, just in time to meet demand. So how do we implement SyteLean? Well, it's actually pretty straightforward. There's 5 steps to implement. The first step is to configure your SyteLean parameters. So you'll begin doing this by setting up your warehouse-specific parameters in the SyteLean parameters form. That'll include things like setting up the service levels, the lead time factors, which determines how much your buffer should be impacted by the length of lead time for your items, average daily usage, a few other factors that we'll take a look at in a minute here. The next step is to identify the item candidates. So SyteLean is not meant to be necessarily, it could be, but not necessarily be implemented for every single item in the system. There is analysis that you can do using tools in SyteLean to identify which of your items would benefit from a lean manufacturing principle implementation. Selection of items to be included in the automated pull system depends on many factors, including the frequency of usage, the amount of variability and demand for the item, and the cost of the item. There is a simulator tool that can be used to evaluate potential items to be included in the pull manufacturing system. Once you've identified your item candidates and what would be a good fit for pull manufacturing, the next step is to load those items into the pull item maintenance. So pull item maintenance is a record in the database where you store lean items to be acquired through lean manufacturing means, and track and update the inventory profiles in that area. So the next step leading into that segue is to actually populate the inventory profile for all SyteLean items. So there's a utility that will do this for you. So it doesn't require manual intervention. It will, you can run the utility manually, you can run it in the background nightly, and what it will do is it will calculate the average daily usage, the standard deviation in historical usage, the calculated safety stock, the trigger or reorder point for the inventory, the maximum supply, economic order quantity, strategic buffer, and so on. Finally, once you've done that, the last step is to run the buffer status utility. So that's something that we recommend you run overnight after MRP or APS is run. And what the buffer status utility will do is it will compare inventory profiles against actual on-hand quantities and on-order quantities, and it will generate replenishment orders as needed, ensuring that you maintain optimal inventory level. All right, so just going to talk a little bit about each form here. So this is the SyteLean parameters form. This is where you set those parameters that we talked about. So you can define the parameters by warehouse, as you can see here on the left. And the fields that we want to look at here are the lead time factor, default service level, these average daily usage parameters, and the weight factors. Those are the main areas I want to take a look at here. So the default lead time factor, that's a value between 0 and 1 that you set. And this is an industry standard setting. So 1, it means that you've got very short lead times. 1 meaning, multiply by 1, there's no impact to your buffer calculations or replenishment calculations. 0.4 to 0.6, if I remember correctly, that's considered a moderate lead time. So right now we're smack in the middle of that, and then anything below 0.4 to 0.1 is considered a long lead time, and therefore will significantly impact the calculations for your buffers and your trigger points, etc. The service level for any of you that have done any kind of sophisticated safety stock calculations and determining what your safety stock level should be. Service level will be familiar to you. So service level is a number that corresponds to standard deviations from the mean for average inventory usage. And it's used to determine what is our acceptable level of service to the customer where we would allow stockouts or would not allow stockouts. So a 95% service level means that your standard is to have inventory to fill customer orders when they come in 95% of the time. Now, one thing to keep in mind about the service level is, I don't have the exact numbers in front of me, but an increase in service level, there is an exponential increase in the amount of inventory level required. So I believe it was between 90 to 95% service level would require a doubling of your on-hand inventory in your buffers. This is a note. I can get those exact numbers if anybody's interested as well. I just have to go take them out. All right, so yeah, just want to talk a little bit about a few other fields here. So the average daily usage parameters, that essentially includes the range of transactions or customer orders in the system that will be considered when determining the buffers at each stage of inventory. So in this case, we defined it as weeks, and we've said we want to look 13 weeks back into material transactions and look 13 weeks forward into any customer orders that are in the system. Now, these average daily usage transactions that are within that time frame will be used to calculate the weighting factors. So the weighting factors on the right here, these will control how historical and future data gets used to calculate the average daily usage. This is an example. We've got an item that has a historical usage of 100 units per day and a future forecast of 135 units per day. How do we blend that? How do we determine what our average daily usage is for the SyteLean lean management buffer calculations? How do we determine that? Well, 100 units per day historically, a future plan for 135 units per day based on customer orders. Sorry, I said forecast. It's actually actual orders, as I said before. Based on the number of days before and after, you would determine what the weight of the calculation should be. So there's a calculation that the system will do to determine what the weight would be, and then it will basically determine how it should weight the history in the future to determine the average inventory level. All right, so just gonna jump back here to the steps to implement. So we've talked about the SyteLean parameters. Next, we're gonna go through each of these and discuss the forms in SyteLine and the utilities in SyteLine that will actually be used to implement. So SyteLean simulator, I mentioned this when I was talking about the identification of item candidates. So the simulator tool is used to review the items that you have set up in your system, review the historical transactions that have occurred with those items, any orders that are in the system for future demand, and present the data in an output format. In this case, it's a CSV file, as you can see down here. So this tool is used to both allow you to perform analysis and provide a recommendation of which items could benefit from lean manufacturing methodology. So once you've got your output, the data can then be used to identify items that exhibit characteristics of a pull item candidate. Some of the characteristics include if they're, just as an example, if we've got no usage, then it's not a SyteLean candidate, obviously. You're not going to build something that you don't need to build in a lean manufacturing environment. If it has no lead time, as an example, then it's also not a good it's not a good candidate either, because lead time gets used in the calculation to determine safety stock and trigger points. So if you don't have any lead time, you can acquire it instantly and you don't need to maintain it. Now, what is considered a good fit item for SyteLean would be an item that has a predictable rate of consumption and has a good ratio between average daily usage and the standard deviation. So the standard deviation being smaller, average daily usage being more stable, can provide indication that an item may be a good fit. So just keep in mind, in some cases, there may be items that seem like they might be a good fit for lean manufacturing methodology, but there are in certain cases better options, such as vendor managed inventory. I know some of you in this call use vendor managed inventory. That's a good example of where you do have a lean system, but it's managed by your vendor and not by you. So when items are being selected for use in SyteLean, things to consider include the usage frequencies. So items with high and consistent usage are the best candidates. Demand variability, items with lower variability are easier to manage. And cost. So high value items, obviously we want to optimize the inventory levels for high value items because there's a significant carrying cost of holding too much inventory. All right, so once you've determined what your lean items should be, the formula they get populated in, I call it the pull item maintenance. Sorry, I call it the pull item maintenance. And it's also called the SyteLean items form, depends whether you search by caption or by name. So this form includes item specific information that's populated, including from the items form, from the item record, including source, product code, unit of measure, revision on an inventory, lead time, day supply, order multiples, and so on. That information gets automatically populated in here. And this is also where information that is an output of the calculations from SyteLean will be stored as well. So once you've loaded your items into the SyteLean items form, then what you'll do is you'll run the SyteLean buffer data utility to populate the inventory profiles. So this utility will calculate the average daily usage, the standard deviation in the historical usage data, the calculated safety stock, the calculated trigger point, the calculated maximum supply, and the strategic buffer. So the definitions of each of these factors are average daily usage. Obviously, as I mentioned, it's calculated using historical material transactions and future actual demand data via customer orders. If it's a purchase part, it could be job demand, it could be project demand, etc. The standard deviation is where you'll measure that demand variability, which is a critical portion for calculating the safety stock. Safety stock, obviously, we talked about that. Trigger point, some companies will call this a reorder point. SyteLean calls it a trigger point. It's the inventory level at which replenishment is triggered. The maximum supply is the highest inventory level that will be allowed in order to prevent overproduction, so the buffer is no larger than it needs to be. And then the strategic buffer will represent the typical or average inventory level. So just as an example, if we have an item that's got an average daily usage of 10 units, a future average daily usage of 11.4, and a 13% difference, don't worry about doing the math here, but that would be a calculated average daily usage of 10.8 units with a standard deviation of 11.7 units. So there's a lead time of, say, 20 days. The service level that we want to maintain of about 80%. We may calculate a maximum supply of 370 units with a 260 unit trigger point. We'll take a look at an image that demonstrates this in a minute. All right, so once you run your SyteLean buffer data utility, then it will populate information in the inventory SyteLean item, the inventory profile. So in this case, it has calculated a maximum supply, a trigger point, a safety stock, strategic buffer, the number of standard deviations, and the average daily usage. So it will update information here after you run that status utility. So from this inventory profile, we can immediately view the minimum inventory requirements, the current inventory levels, and the current on order supply balances. So here's a visualization of what we're looking at there. So maximum supply in this case is 369, trigger point is 261, lead time 217, strategic buffer 98, and safety stock 44. So the orange area represents the desired safety stock level right here. The green level, so that's 44 units right there. The green level here, this represents the area between the maximum safety stock and the trigger point being 261 units. So this is the inventory that is expected to be used during the lead time to replenish the buffer. Okay, so safety stock. For those of you that I've worked with on implementing safety stocks, you'll probably remember me saying that safety stock, you're not meant to fall below safety stock. Safety stock is it's a backup just in case. It is meant to be essentially the new on-hand inventory level of 0. So in this case, we've got a safety stock of 44. From a planning and manufacturing standpoint, we never want to drop below 44 units of on-hand inventory. The only reason why we have 44 is in a worst case scenario where we have a bump in demand, a variability in demand that increases the amount of demand, we've got enough inventory to be able to serve the customer without having a stock out. So the trigger point represents when we would place a new order. So this green portion here, this is the inventory that we would use during the time to replenish the new order. Now, between the trigger point and the maximum supply, that is our inventory that we maintain once we've received the reorder. So when the trigger point is replenished and we receive the new stock quantity, that brings us to our maximum supply. This is the inventory that we draw down before we trigger a reorder. So that's what the information for the total inventory profile actually means and populates. All right. So the last step in initializing SyteLean, setting it up for usage, is to run the buffer status utility. So the other utility is called the buffer data utility. That's to populate your inventory profile. This utility is the buffer status utility, and this is what generates replenishment orders. So the buffer status utility will compare the inventory profile against your on-hand and on-order inventory quantities to initiate signals to replenish. As I mentioned before, this utility you always want to run in the background at night after APS or MRP runs, never before. The buffer status utility output, there's two outputs. One, there are new replenishment orders, and two, there are exceptions. So similar in a planning environment, exception messages to reschedule advice and provide information about any spike notifications. So I didn't talk about spikes. We're looking at the SyteLean parameters. I'll just jump back to that here. There is a spike percentage here. So what this means is when a notification will pop up and when the replenishment factors will change based on what inventory demand spikes to. So if it increases 50% over typical demand for a specific time frame, that will initiate a spike, which this utility, this buffer status utility, will provide information on. So the buffer status utility uses standard SyteLine interface. So if you don't perform automatic order replenishment, which is an option in your parameters, then you'll use generally speaking, the material planner workbench to replenish inventory for your lean items. This will alert the user, the planner, that there's a requirement to make or buy that item. The order details that will be populated on that workbench, if you are not automating the creation, will include the release date, will always be today's date. You need to release it right now because it's just in time. The due date will always be today's date plus the item's lead time. The order quantity will always be the buffer action quantity that's calculated by SyteLean, modified by any order minimums or multiples that you assign. And then a PLN number with a reference of SyteLEAN PullSystem replenishment. So you have an indication that it's coming from SyteLean and not from APS or MRP. All right, so we've talked how to implement. We talked about what lean management means in context of SyteLean and Syteline CSI. So the benefits of SyteLean. The main benefits are it's a reduction in waste, essentially, reduction in overproduction. So SyteLean allows us to produce only what's needed, reducing waste and other associated costs. It allows us to improve our inventory management. maintain accurate inventory profiles, and automated replenishment will help us with maintaining optimal stock levels and more timely replenishment of inventory when it's needed. Another benefit of SyteLean includes the enhanced efficiency. So because we've streamlined our production processes, this should lead in most cases to higher productivity and reduction in lead times. One of the biggest benefits of lean manufacturing outside of reduction and waste is also the increase in responsiveness. So our production system can quickly adapt to changes in actual demand so that we can better meet our customers' needs. All right, so today we've discussed the principles of lean management, the concept and benefits of pull systems and automated pull systems. We had a brief overview of SyteLean and the steps to implement. And I'd just like to say that as with any kind of continuous improvement, lean methodology is an ongoing journey. Adopting continuous improvement throughout your organization and lean practices at every level of the organization are essential in order to stay competitive and meet your customer demands. So if any of you are interested in reviewing SyteLean further, I'd encourage you to consider how it can benefit your organization. I'd be happy to talk with you specifically in more detail about how it could potentially benefit. All right. Thanks, guys, for watching the presentation. I'd like to open the floor now to any questions. Please feel free to ask about anything. If you think of any questions later that you don't recall, that you don't think of now, you can reach out to me if you need my contact information. And you can talk to Con after the call, or Con, maybe you can provide it in your follow-up.
Yep, sure.
I'd be happy to discuss any questions that you have.
We have one question, Brandon. Reza said, I may have missed this, but if buffer level goes lower than a safety stock level, does it send notification to some assigned people for replenishment or a kind of warning notification?
Yeah, I mean, in order for the buffer to fall below the safety stock level, you would need to have a spike in demand, as we just talked about spikes. So when there's a spike in demand, there are specific reports that you can run and you can automate that will provide you analysis of those spikes and information. And you do get notifications from your planning detail, your workbench, etc., when spikes have occurred.
Mm-hmm. And we have one more question from Arvin. Does SyteLean can provide status report or dashboards?
Sorry, I was just reading one of the comments here. Can you repeat that one, please?
Does SyteLean can provide status report or dashboards?
Yeah, I mean, dashboards, there's not a ton of dashboard functionality in general in SyteLean. In my opinion, we've got some homepage dashboards, but a lot of the dashboard functionality is accessible through the Infor OS portal, which is part of the interface for cloud clients. Yeah, I mean, as far as reports for SyteLean, there are a number of different reports that can be used to analyze the inventory replenishment, the reorder points, the spikes, as I said, the inventory profiles, etc.
And thank you, Brandon. And we have one more question from Marvin again. Is there the ability to forecast demand within SyteLean as well?
So, yeah, it's a good question. One of the principles of the lean methodology in SyteLean is that you do not plan based on possible demand. You plan based on actual demand. So forecasts are not a good fit if you are using SyteLean for specific items. Forecasting, I would use an alternate planning method, such as APS.
And actually, we have another great question from Arvin. Does it have the ability to connect to CPQ?
So it doesn't connect directly to CPQ because, and I'm assuming you're probably referring to promise dates. So CPQ will I mean, I don't work with CPQ closely personally, but if I recall correctly, it will allow you to get promise dates from APS. So think about how lean manufacturing would be implemented for a make-to-order organization. So if you're using CPQ, you're not make-to-stock, you're make-to-order or at least assemble-to-order, meaning that you don't carry finished good inventory because you make custom product, right? So you maybe carry sub-assemblies, you definitely carry raw materials unless you're an engineer to order. So you could implement SyteLean and lean manufacturing principles on the sub-assembly and raw material level, but you wouldn't implement it for the finished goods because you wouldn't carry a buffer of finished good inventory situations. Meaning there's no need to connect to CPQ. The creation of orders in your ERP from CPQ will trigger the SyteLean process for the components and raw materials.
Okay. And we have one more question, Brandon. Thomas asks, what's the typical time frame for full integration of SyteLean?
Yeah, I would say, I mean, as with any implementation in SyteLine, it really, what you put into it is what you get out of it. So it is a smaller module. So definitely if you put time into testing and validating, you can get it set up in a matter of weeks. But yeah, I mean, as with any planning methodology, it requires testing and validation and monitoring of different scenarios because it is a planning methodology. It's an alternative to using APS or MRP.
And we have one more question. Is there any chance to analyze bottlenecks per product within SyteLine and have different buffer management? That's a great question.
Bottlenecks per product. Are we talking about item bottlenecks or are we talking about resource bottlenecks? Be able to respond to that, Arvin? Okay. I'll just answer regardless. So yeah, I mean, bottlenecks are, if we're talking about resource bottlenecks, that's more of a theory of constraint concept. So there is functionality in SyteLine to handle analyzing bottlenecks, and that's done through the APS module or the scheduler if you're not using APS. So that allows you to manage the utilization and monitor the utilization of your workstations and even set them up for finite capacity planning so that they can exceed 100% capacity and run the pace of production through the shop floor. So generally speaking, lean management and theory of constraints are two separate trains of thought when it comes to optimizing production and increasing throughput at your organization. They can work together in tandem to an extent, but there are some differences in the methodology. However, yeah, I mean, there's no analyzing of bottlenecks from a planning perspective in lean management because lean management is strictly revolving around replenishing inventory based on a buffer. Now, any routing step that occurs as a part of that, you can model as a bottleneck if it's a critical resource. But it's not part of the SyteLean module itself, it's part of APS. If we're talking about item bottlenecks, to me, item bottlenecks just means item shortages. And yeah, and there's nothing specific that would require different buffer management in that area, at least from my interpretation of the question.
Okay, we still have time, so please ask your questions if you have. We have one more question from Gabriel Brandon. Is SyteLean suitable for both small businesses or large enterprises? So what's the scale of the company for the best fit?
Yeah, it's I would say all of the above. I think that it is a good fit for any organization that wants to follow those lean manufacturing principles that we discussed, regardless of size.
Mhm. So, yeah. Okay.
And I just reading through the messages here, I noticed that a few of you mentioned that you're having some feedback issues. And Con, I don't think you didn't have any issues on your end, did you?
So sorry, what
Just in
feedback?
terms of microphone, sounds like there was choppy microphone
Yeah,
issues.
and some of our guests had some problems with the audio, but I think it's resolved our internet connection problem. But
Okay.
anyway, if anyone had any problem with the audio or video, don't worry, we will send you a webinar recording copy today. So okay, do we have any more questions about Infor SyteLean? Okay. I
All
think
right.
we don't have.
Yeah, thank you all for joining. And if any of you would like to speak further, if you don't have my contact information already, Con will be providing it in his follow-up email.
Yeah,
Thank you, guys.
definitely. We will send you a webinar recording copy today, and you will receive a document about Infor SyteLean. So if you have any questions about the module, please let us know, and we can discuss. Thank you so much, and have a great day. Thanks for joining us today. See you in the next webinar.
Take care. Bye now.
Bye-bye.